first example of today's lecture is about the company Electropoly, who is making slip rings. Okay, so the company Electropoly is making slip rings, and they received order which is a value of $750,000. And the company produced three different products: Model 1, Model 2, Model 3. So number of orders they received, 3,000 for Model 1, 2,000 for Model 2, 900 for Model 3. And the process for making these slip rings, regardless of models, and they need two jobs, processes, wirings and harnessing. So hours of wiring to produce 1 unit of Model 1 will take 2 hours, 1.5 hours or 3 hours for Model 2 and Model 3 respectively, while hours of harnessing to produce 1 unit of Model 1, 2, 3 are 1, 2, and 1 hours respectively. However, the company has a limited capacity for manufacturing process. So the capacity is limited by two processes of wiring and harnessing. The company has 10,000 hours of wiring capacity and 5,000 hours of harnessing capacity. Anyhow, the company received the orders 3,000, 2,000, and 900 for Model 1, 2, and 3 respectively. So the company don't want to lose any customers. They want to meet the demand to be competitive in the market. So the company decide to make a certain number of products for Model 1, 2, and 3. And if they cannot produce all of them, they're gonna buy the same product from the company's competitor or competitors in the market. So I'm gonna go with the steps we haven't learned regarding linear programming. So first step is identify the decision variables. So let me ask, what are the decision variables with this example? You have three models, Model 1, Model 2, Model 3. So from previous lectures, we just use the label of X to define the decision variable. Let's just X1, X2, X3 for Model 1, 2, 3. But do you see my whiteboard anyway?
I can see it.
I can see it.
Do you read X1 and X2, X3, right?
Yes.
All right. Okay, so we're good to go. I'm gonna make it a larger font. So let's say X1 to represent Model 1, X2 representing Model 2, X3 representing Model 3. But as the example said, the company will buy, make or buy. Little bit larger. Make or buy. All right, here's the example. There is a 3,000 orders for Model 1, and then 2,000 orders for Model 2, and then 900 orders for Model 3. If Electropoly decided to make $2,000, how many Model 1 the company need to buy?
1,000.
1,000 is correct. Now you see the pair, right? They receive 3,000 orders, and if they make 2,000 Model 1, they need to buy 1,000 Model 1 from their competitors. So let's say the number of Model 1 to make M1, the number of Model 2 to make M2, the number of Model 3 to make M3. Then the number of Model 1 to buy is 3,000 minus M1. Let's say this is a B1. So the number of Model 2 to buy will be B2. The number of Model 3 to buy the B3. So you see the pattern. So X2 will be M2 plus B2. X3 will be M3 plus B3. And also M1 equal to M1 plus B1. So the company needs to make a decision on those numbers, M1, M2, M3, B1, B2, B3. So these are the decision variables. The next step is to define the objective function. Question is, the company would like to maximize or minimize? You don't want to maximize the cost. You want to minimize the cost. So we want to minimize total cost. C is making cost plus buying cost. So we have two terms, making cost and buying cost. What are the total making cost? You got the numbers on the slide, and you got the decision variables on whiteboard. So if you produce M1 number of Model 1, what will be the total cost? So $50 times M1. Then for the cost to make Model 2 is, where is 83? 83 times M2. Making cost for Model 3 will be 130 times M3. Oops. And then we need to add buying cost. What is the buying cost for Model 1 per unit?
61.
61. So 61 times B1 plus
97.
Thank you. Times B2 plus
145.
145 times B3. So this is your total cost. We want to minimize this total cost. That's your objective function. Well, this object function is subject to several constraints. What are the constraints of the company? The company has limited capacity in terms of wiring capacity and harnessing capacity.
So when you don't have two decision variables, you have to set up the equation just like this
And then we need to put those equations on
Yeah.
Excel.
on Excel, right? Okay.
Yeah,
All right.
yeah, that's the next thing I need to demonstrate. But anyway, before making spreadsheet model, we need to have a mathematical formula.
So you're going to go over the Excel part, correct?
Yeah, sure, yeah. So we have 6 decision variables and object function, which is subject to several constraints. So we need to identify constraints. First constraint is wiring and harnessing capacity. But the wiring and harnessing capacity are only for making product for M1, M2, M3, not for B1, B2, 3. So be careful with that. Okay, if you produce M1, is it wiring capacity and harness capacity? Okay, let's take a look at the harnessing capacity, wiring capacity first. So if you want to produce one number of M1, you only need 2 hours of wiring, right? So you need 2 hours of wiring for M1 plus 1.5 hours for M2 plus 3 hours for M3. Do you read, right? Then it cannot go over 1,000 hours. Let's take a look at the harnessing capacity. If you produce one number of M1, you just need 1 harnessing hour. So 1 M1 plus 2 M2 plus 1 M3 should be less than or equal to 5,000 hours.
Professor, the harnessing, the wearing is 10,000 hours, not 1,000.
Oh, yeah. Yeah, not 1,000. Yeah, you're correct. Thank you. It should be 10,000, yeah. We have number of orders for M1, M2, M3. Right? So as you said, M1 plus B1 should be equal to 3,000. So let's say this is a demand constraint. Produce M1 plus by 1 should be equal to 3,000. M2 plus B2 should be 2,000. M3 plus B3 should be 900. Then we also have a non-negativity constraint which M1, M2, M3, B1, B2, B3 should be greater than or equal to 0. This is the mathematical programming we have for this example. Do you have any questions so far? So do you see my Excel?
Yes.
Yes. Okay. Let's make it a little
Yes.
bit larger. Thank
Yes,
you.
please. Thank you.
Okay. So, model 1, which is X1. Oh. And model 2, model 3. So let's say this is X1, X2, X3. We need to decide how many products we make. Say this is a decision variables. Number of products to make and number of products to buy. So we need to decide, right? So gonna have so let's have a placeholder for these decision variables for better understanding. We need to decide these decision variables. Okay, the cost to make. Cost to make 50, 83, $50 for model 1, 83 for model 2, 130 for model 3. Is that correct?
Yes.
Thank you. Right, so. What is the total cost to make the number of product of X1 and X2, X3? So we're going to have formula here. So we can use a function sum product, right? Because this is a cost to make. So we need the decision variables of these 3 cells. And the cost information from these 3 cells. And then close the parentheses. And total cost of 263. Is that correct? Is the number correct? If we put 0, 0, 0, the cost should be 0. Okay. If you only produce model 3, the cost is 130. So I think the formula is correct.
Yes, that's correct.
Yeah, thank you. Then we got information of cost to buy, which is 61.97, 61.97, and 145 for model 3. So total cost to buy will be, we can use some product function. So these 3 decision variables with this cost information to buy. So the total cost to buy those products will be 303 with the placeholders of 111. for model 1, model 2, model 3, respectively. So now, total cost will be sum of making cost and buying cost. Making cost plus buying cost. So this is our objective function to minimize. Right? So let's say any questions so far?
No, thank you. I'm good.
Thanks. Then we need to define constraint. Okay, so total number of products to buy and make will be sum of these two decision variables. Right, so I'm going to copy this formula for other models. This number is buy, oops, is a buy plus make. That should be equal to the number of orders that the company received. 3,000 for model 1, 2,000 for model 2, and 900 for model 3. Right? So these three cells are the left-hand side. And these 3,000, 2,000, and 900 are our right-hand side of the equation. So again, in other words, if we decided to produce 3,000 for model 1, we don't have to buy any model 1. If we decide to produce 2,000 for model 2, we are not going to buy any model 2. And if we decide to produce 900 for model 3, we are not going to buy any model 3. So you see, this is sum of those two decision variables should be equal to the number of orders. Then we have wiring capacity and harnessing capacity. To make 1 unit of model 1, we need 1 hour and 2 hours for model 2, 1 hour for model 3. And in the same way, let me change this. Hours of wiring. This hours of harnessing. So we need 1 hour. Oh, something wrong, right? That should be 1, 2, 1. And wiring, 2 hours for model 1, 1.5 hours for model 2, and 3 hours for model 3. Okay, and let's make a little bit smaller, right? So total number of hours of wiring to produce M1, M2, M3 will be, okay, so total hours, this is the left-hand side of the constraints. So we can use some product to make with these 3 models, and with this number of hours of wiring for each model. So to make sure the formula is correct, let's have placeholders, which is a small number. So if you produce model 1, model 2, model 3, we need 6.5 hours. We're gonna do the same thing for harnessing. We can use some product to make model 1, 2, 3 with the information given to us. These are the left-hand side of the constraints of wiring and harnessing. So these total number of hours should be less than or equal to 10,000 for wiring, and less than or equal to 5,000 hours of harnessing. Okay, so I have a question from the chat box. So now we have 3 constraints and 2 constraints of wiring harnessing, 3 constraints of demand constraints. Now we are ready to run the solver. To run the solver in Excel, go to File and select Options. And on the left-hand side, you will see Add-ins. And scroll down on the bottom, your Excel add-ins with the button Go. If you click, you have add-ins available. So you need to check solver add-in, then click OK. Once you add the solver under the menu, so that's a little bit more, under the tab Data, and you will find the icon solver from the ribbon menu. Okay, let's open solver pop-up window. We need to let the application objective function, which is H9. You can just click the green cell, and we are maximizing or minimizing.
Minimize.
Minimizing, thank you. Minimizing total cost on cell H10. So by changing variable cells, we'll need decision variables. Oops. Decision variables highlighted in yellow. 6 decision variables. And we also need to define constraints. Click Add. Okay, so we have a demand constraints which are contiguous. So we can select the range T12 through F12. Then we have a same equal sign. And then constraint will need the right-hand side, which is 3,000, 2,900. So we need to add another wiring and harnessing constraint. So click Add. So total number of hours of wiring harnessing with the formula, which are left-hand side. So I select the range of these two because you have the same signs of these constraints. Those will be less than or equal to right-hand side. That's all we have. So click OK. Now we need to set up non-negativity constraints. So you see the checkbox, make on constraint variable non-negative. So you check. If you don't want to check, you need to add those non-negativity constraints in this constraints setup box. So we'll check this. And we're going to use simplex linear programming, which is algorithm. So we are done. So we are done with the setting the parameters. We are ready to run. So if you click solve, the message says, solver found the solution. All constraints and optimality conditions are satisfied. So we want to keep solver solution. Okay, so the radio button of keep solver solution is checked. And I click OK. Now, if you see the solution, the company will produce 3,000 Model 1, 550 Model 2, 900 Model 3. The company will buy 1,450 Model 2 to minimize total cost. So total cost is 553,300. Do you see the solutions? A total number of hours of wiring harnessing and hours of harnessing exhaustively consumed, while hours of wiring has extra labor hours.